Hi there, everyone. I thought we could go through a Hardy-Weinberg problem today. So let's have a look at this problem here. And then what I'm going to do first of all is write out the equations that we need, and then we'll just go through those. So first of all, we've got P plus Q equals 1. And then we have, of course, P squared plus 2PQ plus Q squared equals 1. We'll just go through what each one of these means. So first of all, we've got the first equation, which is actually frequency of allele. So this is telling us how many recessive alleles there are in the population, how many dominant alleles there are. So generally we say the P represents the dominant alleles and Q the recessive. So it's the exact number despite whatever individual it is within the population. Okay, and it equals up to 1. P squared plus 2PQ plus Q squared equals 1 is the genotype. This tells us the genotype. So P squared is homozygous dominant. 2PQ is heterozygous. And Q squared is homozygous recessive. Okay, so this is going to help us to work out whatever they want us to do in the question. So let's have a look at the question quickly. So in corn, purple kernels are dominant to yellow. So this is telling me that the yellow trait is recessive. That means in order for us to actually get a yellow kernel, we need 2 recessive alleles in its genotype. Okay, it then tells us that a random sample of 100 kernels is taken from a population in Hardy-Weinberg equilibrium. So the total number is 100 in that population, which will be useful later. So it is found that 9 kernels are yellow and 91 kernels turn out to be purple. So that means the 9 kernels that are yellow must be homozygous recessive. Because if you remember, in order for us to get a yellow kernel, they have to have 2 recessive alleles. So they're homozygous recessive. So it says then, what is the frequency of the yellow allele in this population? So this is the sticking point, I think, for some students. They trip up here. You need to know exactly what they're asking you to find out. Now, this question is a little bit easier than others, but we can definitely see here which equation we need to use first. Or which equation we're going to be using eventually. So we're trying to find the frequency of the alleles. So this one here, we're trying to find out Q, because remember the yellow allele is recessive. So we need to find out what Q is, and then we need to use the information they've given us to actually work out what Q is. So what information do we have? Well, we have the total population, which is 100, but we do have that 9 kernels were yellow. Now, they're homozygous recessive. So we also have that information, which is Q squared. So I can try and work out what Q is by using the Q squared information. So I know that Q squared equals, and this is where we have to now turn it into a proportion of the population. We do 9 over 100. And you can't just put 9 here, because if I put 9 into that equation, that's going to be more than 1 at the end, isn't it? So it has to be a proportion equaling up to 1. So 9 divided by 100 is equal to 0.9. Now, in order for me to get Q, all I need to do is square root 0.09, and Q would equal 0.03. So I've now got my answer, which is the frequency of the yellow allele in this population is 0.03. So just remember, go back through the question, try to identify, first of all, which part of the equation they're asking you to work out, and then use the data appropriately. And remember, it has to be a proportion of the population. Don't just simply use the numbers and input into the equation. Okay, I hope that helps.